Okay, so this video we're looking at the cosine rule again, but this time we're looking at finding missing angles in non-right angle triangles. So it says up here, right, we're looking at finding missing sides and angles. This is just taken from the lesson, but this video is just looking at the cosine rule to find missing angles. Okay, last video we looked at finding missing sides, but now we're on to missing angles in non-right angle triangles. Again, really important, because the sine rule, the cosine rule, grade 5 trigonometry, so SOHCAHTOA and Pythagoras, the most important thing really with these is identifying how you label up your triangle and recognizing which one to use, because actually using them isn't too tricky. It's not too bad, it's just really substitution. So we talked about last video how if you're given a triangle that looks like this with an angle and two sides adjacent or next to that angle, you can use the cosine rule to find a missing side opposite your angle. We looked at that on a previous video, so that one has been done on the previous video. Today we're looking at finding missing angles using the cosine rule, and we can use the cosine rule to find a missing angle like this one here, M, if you're given a non-right angle triangle with three sides given to you. Then you can use the cosine rule. So you've got to be able to recognize that kind of triangle, which is quite a nice one to remember. Okay, it's just three sides and your angle. Again, the cosine rule, what is it? What are your formulas? So we've already looked at this top one, which is to find missing sides using the cosine rule, which is given here. So that one's been done in the previous video. But today we're looking at finding missing angles, which is given by this formula here. And very important to bear in mind, this top formula is given to you in the formula booklet, but this one here, finding angles, is not given to you. So you've basically got to memorize it. You can rearrange to get it, but I haven't gone through that yet. So I would say just memorize this and you're going to be good to go. Again, this is how we label up our triangle. Hopefully this has become sort of second nature from our previous videos. Your three sides, lowercase a, b, and c, and your opposite angles, capital A, B, and C. Okay, let's get into it. And again, right, you might want to make a note of this. This is your formula that you're going to need for this video for finding missing angles using the cosine rule. Let's begin. So I'll go through my turn, your turn, and there'll be two examples you can try yourself at the end. Right, the first my term. I want to find this missing angle M here, and importantly, because I'm trying to find that angle M, using my formula, let's go and label up that angle, capital A. So angle M here, I'm going to go and call capital A. And then importantly, your side opposite that angle is going to be your lowercase side a. And that's important. And then your two other sides, your two remaining sides, you can go and call B and C in either order. So you could go and call that B and that C, or you could call this B and this C. It makes no difference. I'm going to stick with this because why not? So using our formula now, it's just a case of substitution and then going from there really. So we've got cos of the angle A. So cos of the angle A, where A is equal to M. That's what we're trying to find. Cos of the angle M is equal to B squared is C squared, where B and C are 7 and 6. So 7 squared, add 6 squared, minus A squared, where A is equal to 8, lowercase a. Let's go and put it in brackets just to be really safe. 8 squared over 2bc, which means 2 times b times c. So 2 times b is 7 and c is 6. So 2 times 7 times 6. And then I recommend from here, you could do this in different ways, but I recommend you put this first of all into your calculator and we'll go from there. So we're going to get cos of your angle M is equal to, and I'm going to type this in nice and carefully, which is important. So let's go and put that in. So if you've got a Casio, this shouldn't be too bad. You can follow along how I say this. So we've got 7 squared, add 6 squared, minus 8 squared, over 2 times 7 times 6. And that's going to give us 0.25, which is quite nice. Okay, so no long decimal, so 0.25. And then in class, some of us were saying, well, how can angle M be 0.25? We're not finished yet. We've got cos of the angle M. To find M, okay, you've got to go and do the cosine inverse, because cos M, let's get rid of that cos, you've got to do the cos inverse of both sides. Okay, if we do that, we can get our answer. So cos inverse 0.25 is going to be equal to whatever it's equal to, which is 75.5 degrees to 1 decimal place. Okay, and that there is your answer. So, good. So what you can do now is you can pause the video, give that your turn a go, and then you can fast forward and see if you got it correct. If you got it wrong, you can always go back and rewatch it with me. Okay, I want to go and find the angle n. Using our formula, A is what we're trying to find, so it's going to call angle n capital A. Your side opposite, that capital A is going to be lowercase a, so lowercase a, and then B and C can go either way, it doesn't matter, so B and C. And again, it's important to note, right, that we can use the cosine rule here because we're given triangles with 3 sides given to us. That is when we can use the cosine rule, which is important for finding angles. And then from here, just a case of substitution again. So we've got cos of the angle A. Well, angle A is n, what we're trying to find, is equal to b squared is c squared, b is 16, c is 12, so 16 squared, add 12 squared, minus a squared, where a is 7, so minus 7 squared, over 2bc, so over 2 times b. B is 16, C is 12, so 2 times 16 times 12. And then again, go and put this bit here into your calculator. You could go and write cos inverse of this bit here, but I'm going to break it down just to make it a little bit easier, hopefully. So cos n is equal to, and then go and type that into your calculator. And again, if you've got a good calculator, it becomes relatively straightforward. You just go and type it in carefully, and we should be good. 2 times 16 times 12, which is 0.914, 0.914. And it's important here because this here isn't our final answer. You want to use quite a few decimal places just to make sure we don't get any rounding errors at the end. So that's cos n is equal to this. And note, it is important that when you've got cos, sine, cos, or tan, of something, it's always got to be less than 1 or bigger than minus 1. So between minus 1 and less than 1. If it's not, you'll get an error on your calculator. Anyway, to go and find n, that's going to take the cosine inverse of this number here, so 0.91406. So n is going to be equal to cos inverse of our answer, which is 23.9 degrees. Okay, and hopefully that is correct. If you got that, then good work, really good. If you got it wrong, you can always rewind and go where you need to. So just quickly, here are 2 examples for you to try. So you can pause the video again and give both of those a go. Look, this is just the real fundamentals, okay, of the cosine rule for finding angles. So nothing too crazy going on here, but good practice, okay? Because when we get onto the trickier examples on a later video, we look at mixing them all together, the sine cosine rule. Knowing these rules well is really, really important. So give those a go, pause the video, and you can fast forward to the end to see the answers. So question 1, you want to find the angle here, which is theta. So we're just calling it this thing here, which is called theta this time. Again, that's going to label this up. We're trying to find that angle. Let's go and call that angle A. Your side opposite will be lowercase a, and then B and C can go either side. It doesn't matter, B and C. And then plugging it into your formula. So we're going to get cos of the angle A, which is theta. That's what you're trying to find, is equal to b squared is c squared. B is 8, so 8 squared. C squared. 9 is c, so 9 squared. Minus a squared, where a is 10, so 10 squared. Over 2bc, which is 2, times b, which is 8, times c, which is 9. Go and plug that into your calculator. So we're going to get cos theta is equal to, type this in, 8 squared, add 9 squared, minus 10 squared, over 2 times 8 times 9, doing it really carefully, and you should get 0.3125. That's not our answer. You've got to find theta, which is your missing angle. So to find that, you've got to go and take the cosine inverse of 0.3125, which is equal to 71.8 degrees if you round it to 1 decimal place. Okay, of course you may round it differently. 72 is fine, 71.79. As long as you're getting roughly that number, that's really good. So if you got that, then good, well done. Question here is very similar. I'm just noticing though, because this angle here looks obtuse, probably when we get to our cos bit, we're going to get cos of a negative decimal, which is okay, but as long as it is bigger than -1, we're going to be good to go. Anyway, let's just get into it. So missing angle, again, go and call that capital A. Your side opposite is going to be lowercase a, and then B and C can go either side. Apologies for that. Let's turn my phone off. Turn it off. There we go. Good. And then plug it into your formula. So we've got cos of the angle A, where A is theta. So cos theta is equal to B squared is C squared, where B and C are 8.1 and 7.5. So 8.1 squared, add 7.5 squared minus A squared, where A is 14.3. So 14.3 squared over 2BC, so 2 times B, which is 8.1, times C, which is 7.5. Plug that into our calculator, and I'm anticipating a negative decimal here, which is okay. Let's just double check though. Let's see. So 8.1 squared, add 7.5 squared, take away 14.8 squared, over 2 times 8.1 times 7.5 is, negative 0.79983, so on and so forth. So theta is going to be the cosine inverse of that there, which is going to be equal to a angle over 90, which is 143.1 degrees to 1 decimal place. The reason why you get a negative decimal here, it's a bit beyond the scope. I mean, it's A-level stuff. I mean, look, just very briefly, right? Cosine, the graph of cos looks something like this, okay, where this angle here is 90, this angle here is 180. If you've got an angle bigger than 90, like we do here, okay, it's going to be somewhere around here, between 90 and 180, so somewhere around here. That could be, in our case, 143 is here, and that's going to give us a value of minus 0.7, and that's the reason why. Look, that's way beyond the scope, so that's probably a bit irrelevant. Anyway, if you got both of those correct, then that's really, really good. Well done. Okay, that is the cosine rule done. I think we've looked at sides, we've looked at angles. We need to look at mixing them all together, and then we're going to be good to go, really. Okay, so hopefully that was useful. Sorry, I sound a little bit slurry. I'm quite tired, but of course, right, for you guys, this is really important. So hopefully it is useful. Again, apologies, getting a little bit tired. It's getting close to bedtime. Yeah, thank you guys. Well done.